Hey Pre-Calc, Mr. Rashid here, and today we're looking at graphing inequalities. So our learning target today is two parts. We're going to determine first if a point is a solution to an inequality, and then secondly we're going to graph both linear and non-linear inequalities here. So let's get started. So in the case of inequalities then, remember that it's not just the line that's the solution. We have, in the case of linear equalities, half the plane is a solution. So there's lots and lots of solutions. So inequalities have infinite solutions. Now, one of the things we can do to test if a point is a solution is simply plug it into the inequality. If it's true, it's a solution. If it's false, it's not a solution. So let's do two of these. So here, my x and y is -1, -1. So I'm going to plug both of those in. So I write -1 is greater than or equal to 2 times -1 cubed plus 7. And this is -2. -1 cubed is -1 times 2 is -2 plus 7. And that is 5. Now, -1 is not greater than or equal to 5, so this is false. And so that is not a solution to that inequality. So let's do one more. So here now I'm plugging in 2 for x, or 2 for 2 is my y. So 2 is my y, and -4 is my x. -4 cubed plus 7, and 4 cubed is 64, and negative cubed is negative. So this is 2 times -64 plus 7, and that is -128 plus 7, which is a negative number, a large negative number, so -121. So 2 is greater than -121. So this statement, or this works out, so that's true. And so we can say that for 2 is a solution. All right, so remember that inequalities here have infinite solutions. So let's take a look at the process first. How do we graph inequalities? First thing we're going to do is graph the function with the points. Then we have to decide, is it going to be a dotted line or a solid line? Dotted lines have no equal sign underneath the symbol. So it's just a less than or a greater than symbol. Whereas solid lines, you're going to pick up the line there and draw it in. Then the last step is we're going to test a point such as 0, 0. 0, 0 is already on your functions graph, and you can't use that. Just use something else with a 0 in it. If that test point works out, then you shade the region that includes that point. If the test point does not work out, it's false, then you shade away from the point. So let's see some examples. Okay, so the process is graph f of x, decide if it's dashed or solid, or dotted or solid, test your point, and then do your shading. So now the hard part is we would have to graph f of x, and this is one of those functions that's transformed. So the first thing we look for is what is the parent function. We get that in our minds. And in this case, the parent function is y equals absolute value of x. That is the parent function. Now that parent function then has certain key points. So we can create a table of those key points. So -1 is going to go to 1, 0 will go to 0, and 1 goes to 1. Now, there's a transformation involved here. So the y values, we're going to add 1 for those. And so this is 2, 2, 1, and 2. And for the x values, we do the opposite of what's in there. So -5, but we're going to do a +5. So +5, that is 4. And +5 here is 5, and +5 is 6. Okay, so now the ones in blue are my modified x values, and the ones in red are my modified y values. Not the +1 part, but the rest of it. Okay, so my coordinates then are 4, 2, 5, 1. Let's do that again. 4, 2, 5, 1, and then 6, 2. Now the next step is I would decide, is it a dashed or solid shape? And by the way, the parent function is an absolute value, so I'm going to be drawing a V shape here. So is it dashed or solid? Look underneath here, there's no line, so this is going to be a dashed line that I'm drawing. So this is straight up there, straight up there. Okay, third step, use a test point. So I'm going to use 0, 0. If I plug in 0 here, I get 0 is greater than 0 minus 5 plus 1, and that is 0 is greater than -5 plus 1 is greater than, or that becomes positive 5. It says 0 is greater than 6, which is not true, it's false. So I'm not going to be able to shade any region that includes 0, 0. So my shading then is everything in there. Okay, then let's graph this inequality. We have 5x minus y is greater than 10. So this is a line, it's written in standard form. I can divide here, divide everything by 10, end up with 5x over 10 minus y over 10 is greater than 1. And I can replace this 5 over 10 with 1/2. So that is x over 2. And then I can read my, so my x-intercept is 2, 0. And my y-intercept here is -0, -10. So 0, -10 be down there. 2, 0 is over here. And so let's draw in this line. And yes, I made the decision already. That's going to be a dashed or dotted line because there is no equals sign underneath that. Okay, so let's use our test point. We'll use 0, 0 again. So 0 is greater than 10. That is false. So I'm going to be shading this region here.